Hello student, welcome back to our class. So today we are going to look into a new chapter. So in this chapter we'll look into single phase system. So when single phase system means we will encounter problems either only in solid phase or liquid phase or gas phase. Right. The purpose of this chapter is to determine PV and or T of a substance when you are given some information. So you have to determine the pressure, the volume, number of mole on T of a substance using the information given. So this is what we are going to look at for this chapter. Physical data of substance actually can be obtained via experiment, estimation or calculation using data provided, and also we can obtain the physical data of substance using handbook. Pretty much what we will cover in this chapter is, first of all, we will look into solid and liquid densities. Solid and liquid densities, if we know densities, we can find volume and also mass of the substance. Okay, so and then after we completed with solid and liquid densities, we will look into ideal gas, single gas, where we will going to find P, V, N or R using this equation, PV equals to nRT or P V dot equals to RT, where this V dot means specific, where this V with a dot here means specific molar volume, which is actually V divided by N. So you can find information using this equation for ideal gas, single gas, ideal gas. Right, and then we'll look into the concept of STP, where this is, we use STP, the standard condition when we do not have R, the gas constants. And then if we would like to determine whether our estimation of the ideal gas is correct or not, we will look into R times T divided by P information, so we can determine whether it is an ideal gas, whether the calculation based on ideal gas is correct, or actually we have to use non-ideal gas calculation. And then we will look into non-ideal gas still in single gas, where if we want to find some information related to pressure, pressure, volume, mole, T using these three equations. When you have non-ideal gas, single gas, not a mixture of gas, so we use these three equations. Modification from the ideal gas law, where we use PV equals to Z and RT, where because it's non-ideal gas, we have to find the compressibility factor Z here. So to estimate the information, the information that we want. And then we can also use virial equation and also cubic equation to find this information. Okay, finally in this chapter, we will look into finding information using for non-ideal gas mixture using case rule. So from point number 2 up to number 4, basically all of these are in gas phase. So we'll look in this chapter, we'll just look a little bit on solid and liquid densities, but the main thing that we will learn in this chapter is about gas, whether it's ideal gas, single, non-ideal gas single, or whether it's non-ideal gas mixture. So now we look into solid and liquid densities. As I mentioned before, if we know solid or liquid density, we can find volume or mass. Okay, so right, solid and liquid densities does not change significantly due to the changes of temperature and pressure. Again, solid and liquid density does not change significantly due to the changes of temperature and pressure. Okay, solid or liquid densities are not pressure dependent. So the change in pressure does not change much of the density for solid and liquid. So this is what they are being called incompressible incompressible material. However, changes in the temperature will slightly give some change towards solid or liquid densities. To find density of substance, which is unknown density of a substance, we can calculate using density of water and mercury at different temperature with formulation given in Paris Chemical Engineer's Handbook. In order to find density of liquid mixtures, we have two methods. The first method is based on volume additivity, where this is the equation. So in your textbook, equation 5.1-1, where 1 over density average equivalent to summation of mass fraction of a component in the mixture divided by density of that pure component, summation of them all. So this is based on volume additivity. And the other method that you can find the density of liquid mixture, we can use average, just simply average pure component densities, where density of a mixture equivalent to summation of summation of mass fraction of the component in the mixture times by the density of that component. Okay, so this is given by equation 5.1-2. So I would like you to refer to example 5.1-1 in your textbook, because that example shows you how to determine the density of solution using equation 5.1 that I mentioned before, and also equation 5.1-1 and also equation 5.1-2. So you will look into that example to see how does that both of these equation is being used.